You might think the moon dances gracefully around the Earth, following a simple path. But once you dig a little deeper, you realize that the cosmic waltz is anything but straightforward. The Earth and the Moon orbit a hidden center of gravity, known as the barycenter, which lies just beneath the Earth's surface, not at its center. This hidden balance point flips the script, making the dance of the Moon an intricate one. Imagine a seesaw. If a heavier friend sits on one end, it tilts your way. Just like that, the Earth and the Moon sway around this invisible pivot, their gravitational embrace shaping their movements. But what happens when a third body, like the Sun, steps into this cosmic ballet? The stage gets chaotic, and welcome to the three-body problem, a puzzle that even the brilliant mind of Newton found perplexing. While Newton could calculate the orbits of two bodies, adding a third was like tossing a wild card into a meticulously arranged game. The gravitational pulls of larger bodies, like Jupiter, could upset the delicate dance. This sudden twist left even the greatest thinkers scratching their heads, with Newton admitting he was outmatched. As decades passed, a brilliant French mathematician emerged, undeterred by the chaos. Instead of wrestling directly with the three-body problem, he introduced a clever concept: perturbation theory. He realized that while two objects might follow predictable paths, introducing a smaller third body could alter their orbits ever so slightly. Imagine two players in a tug-of-war, suddenly yanked in a different direction by a small but spirited newcomer. This small shift can have surprising consequences, leading to a booming revelation in understanding dynamic systems, a glimpse into chaos theory. But then comes the bombshell revelation. The three-body problem lacks a general solution. This news hits hard. It turns out there's no one-size-fits-all formula to predict how these celestial bodies will move in the future when gravitational forces interact. A tiny change in position or speed can spiral into chaos, making predictions about long-term behavior nearly impossible. Like trying to forecast the weather based on a bustling butterfly's wing flap, an unsettling reality of the cosmos. Yet, not all hope is lost. Enter the restricted three-body problem, where one body is significantly smaller, like a satellite orbiting a planet. This clever twist allows scientists to make calculations about stable points, known as Lagrange points. Picture NASA's James Webb Space Telescope, parked comfortably at one of these points, skillfully avoiding the chaos of its larger companions. But even within this seeming stability, chaos lurks. Tiny changes can still yield vastly divergent outcomes, leading to dramatic twists in the narrative. Small differences in initial conditions can send a planet on an entirely new trajectory, an unforeseen consequence that might reshape an entire cosmic story. In our grand cosmic tale, while short-term predictions are possible, like forecasting the moon's orbit over a few years, long-term forecasts become labyrinthine challenges. Just as a butterfly affects distant storms, a slight gravitational nudge from an asteroid can redirect a planet's course. Thus, the story of celestial mechanics teaches us that while we can model and simulate our universe's dance, we are forever limited by the chaotic nature of these interactions. In this vast, bewitching cosmos, the unexpected twists and turns of celestial bodies remind us how intricate and beautiful the ballet of the universe truly is. If you like reading, please visit the website of our bookstore, pgbooks.net. There you will find books on a healthy lifestyle, personal development, psychology, business, science, and other interesting things. You can find the link in the description under the video, in the pinned comment, and in the information on the channel. Take steps towards a better tomorrow with PG Books. If you like the content and want to get more of it, subscribe to our channel, and if you have something interesting to say, don't hesitate and write a comment under the video. See you in good health.